Okay, class. So again, a very good evening to all of you. So thank you very much for being here. But I'm sorry to take your time tonight. Maybe you have another plan earlier. Again, thank you very much for your effort. So without further ado, if you are all ready and good to go, so let us continue with our lesson. This is the second lesson on electric and potential difference. Okay, so last week in school, I have give you the introduction to what electric field is. That is the first learning standard in 3.1. So can anybody define what is electric field without referring to your module? Anyone? What is meant by electric field? You can open your mic or you can type your answer in the chat room, okay, as usual.
Charge experience.
Region where a charge experience electric force.
Okay, it is a region where charge experience and electric force. Okay, area that electric covered. Covered what? Form. So it is area where a charge experience and electric force. Okay, region itu area lah. Again, it is a region where charge experience and electric force. Okay. So this is the second learning standard, electric field strength. Okay, so what is meant by electric field strength? So if you look at these two diagrams, student, actually this diagram is taken from your textbook. Okay, you assume we place a positive test charge in an electric field. So this is our road connected to a positive power supply. Okay, and down here we have a road connected to a negative terminal of the power supply. So for this road, it become positively charged road, okay, or positively charged electrode. And for this one, it is become negatively charged electrode. Okay, then we place a charge here. It can be any object, okay, any object with positive charge. So we name it as Q. Okay, so what will happen to this charge? Okay, when we switch on the power supply, so electric field will be occur around this electrode. Okay, this electrode will become an electric field. There is an electric field around it. So we place this object or this positive test charge in this electric field. So what happened? It will experience an electric force. Okay, as you said earlier, what is electric field? It is a region where a charge experience an electric force. So this is the electric field labeled by the blue arrow line, and this is the charge. So it will experience a force. What kind of force? There are two forces it might possible to experience. The first one, according to its charge. Okay, if this electrode is now positively charged and we place a positive charge there, so there are two equal charges. So what will happen to them? So positive will attract or will repel, students? You learned this before in a lower form. Like charges, okay, mean positive and positive or negative and negative. So they will be repel, right? They will be repelled to one another. So the force exists here is called as a repulsive force. So what happened? This charge will be pushed away from the electric field. Okay, so that is the force acting, repulsive force. Why repulsive? Same charges with the electrode. Electrode positively charged and the charge also positive, so repulsive force occur. Okay, repulsive force is experienced by the charge. And then if you look at the second figure, now the terminal is negatively charged. Okay, we have a negatively electrode here. So this is the electric field around the electrode. Then we place a positive charge, that Q. So what will happen? So now they are opposite, negative and positive. So negative and positive, what will happen to them? They will attract. So here, what kind of forces that will be experienced by this charge Q? It will experience an attractive force. So it will move closer to the inside the electric field. It will move closer to the electrons. This one, it will move further from the electrode. So do you understand what electric force exists here that acting on a charge which is placed in an electric field. Are you clear with this, students? Can you follow me? Okay. Okay, they can follow. Okay, follow. Thank you, Yifong. Sikit no. Senang saja, Nicholas. Okay. We put a charge. Okay, if now this charge is negative, let's say Q is now an object with a negative charge. Okay. So we place in a electric field which is connected to a positive terminal power supply. So what happened now? Attractive force occur. Okay, so now Q will be pulled towards the electric field, closer to the electrodes. And now here, okay, if this one is now negative and we place negative charge here, okay, we place an object in this electric field and it is negatively charged. So what happened? You can see that the object will move further from this electrode, mean repulsive force acting on the charge now or on the object now. Okay. Okay, so what is meant by electric field strength, student? Okay, you might write this on the blank spaces in your module. Electric field strength defined as the electric force acting on a unit of positive charge placed at a point. It can be positive or negative lah. Okay, so this is a definition. Again, electric field strength, the symbol is E, defined as the electric force acting on a unit. A unit mean one unit lah. Positive charge placed at a point. So this is the equation. E, electric field strength. F is the electric force. Okay, it can be repulsive, it can be attractive. And Q ini represent the charge, represent the quantity of electric charge. Okay, and this is the unit for electric field strength. Force is Newton, and the unit for quantity of charge is Coulomb. So the unit for electric field strength is Newton per Coulomb. So teacher, electric force is attractive force and repulsive force. Yes. Okay. These are the name of the electric force. If same, mean repulsive force. If different charges, mean attractive force. Okay. So let us go to the next part. Okay, this is another example of electric field which exists in between these two charge plates. On top, we have positively charged plates, and below we have negatively charged plates. Okay, so this is the pattern of electric field exists between them. They are in a parallel line. Okay, and you can draw a dash. Normally, we draw a dash line. Okay, to differentiate electric field line and electromagnetic field lines later on. Okay, when we move to the next chapter. Okay, so what do you see here, student? This is the power supply, positive and negative. Okay, the electric field between two opposite charges parallel are uniform. Okay, if you see uniform means all the distance are uniform between one lines towards to the other. Okay, a uniform electric field represented by a set of parallel electric field lines. Okay. So how to say about the electric field strength produced here? It can be represented by this equation. Okay, the electric field strength produced by two parallel charge plates are E equal V over D. Okay, E, electric field strength. What is V? V is the potential difference. Okay, potential difference between the two parallel. Okay, why there is a potential difference? Because one is connected to the positive and another one is connected to the negative terminal. So potential difference exists between the two plates. And D is the distance between these two parallel plates. Okay, and this is the unit for electrical field energy, electric field strength for two parallel plates. It is volt per meter. Okay, volt for potential difference and for distance is in meter. All right. Okay, so that is to do with electric field strength. Okay, now we move to the third learning standard. Okay, the third learning standard is to see what is the effect of an electric field on a charged particle. So here we have a few examples. A charged particle is, for each example, we place a charged particle in between an electric field. Okay, when I mention electric field, so you're supposed to understand. Okay, so one sources is connected to the positive terminal of the power supply, while another one is connected to the negative terminal of the power supply. So we create an electric field there, and we place an object in between. We place a charge in between this electric field. So as for the first example, you can see here we place a polystyrene ball wrapped in aluminium foil. Okay, we place in between these two metal plate connected to positive and negative terminal of this power supply. So you can read the procedure for number 2, number 3, number 4, number 5, and number 6. Okay. The first one, we switch on the EHT, see what happened. We displace the polystyrene ball, so it touch one of the metal plate and release. So you will see, you will record your observation. What will happen? Either the ball will oscillate back and forth or remain at the center or what. Okay, then second, we repeat step 2 by decreasing the distance between the two metal plate. So you see what happened to the motion. And next, increasing the voltage. So what happened? Either it will oscillating with a faster or at a slower rate. Okay, and number 4, we switch off the power supply and replace the polystyrene ball with a lighted candle. Okay, this is the second example. We place a lighted candle in between the two plates. So what will happen when you switch on the EHT? So we will see later on. Okay, so students, this is the first situation, a charged ball in an electric field. Okay, so this is, if you look at this diagram, this is the EHT power supply. Okay, welcome Aiman. Assalamualaikum. This is the nylon thread, hang the ping pong ball coated with conducting material. Okay, the ping pong ball is now coated with conducting material and it is placed at the center. Okay, students, the first question. Okay, at first the ball is in the middle between the two metal plates. Okay, what will happen when the EHT power supply is switched on? Okay, what do you think will happen to the ball now? It is placed in the middle of the two plates. Okay, what happened when you switch on the EHT? Anything happen to the ball? Yeah, Nicholas.
The ball attracted to the positive terminal.
Attracted to where? Attracted to the positive terminal. Any other answer? Ball bergoyang. Nicholas say attracted to the positive. Why attracted to the positive terminal? Why not attracted to the negative terminal? Yifeng say the ball is movable.
Teacher, the meaning of charged ball is what? The ball carrying negative or positive?
Now it doesn't mention. Now it is coated with conducting material. So we because ping pong ball is made from plastic, right? Okay, so we want to make the ball as a conductor, so it can flow charge through it. So that's why it wrapped with the conducting material. For example, you wrap it with aluminium foil. Okay. Okay, so now it doesn't mention what charge it have. So aluminium foil is the metal. So actually it have both positive and negative charge on it. So now as we place the ball in the middle, so what do you think will happen when we switch on the power supply? Actually, the ball will remain at rest, or the ball does not move. Okay. The ball does not move. Okay, why the ball does not move in this situation now? Okay, because as I mentioned just now, okay, these two plates, one is positive, one is negative, right? So when you switch on the power supply, okay, at the negative side on the ball, okay, on the ball, okay, on the, let's say on the left, okay, I draw a bit here, see, okay. So let's say this is positive terminal. Okay, and this is negative terminal. So means this plate will be positive terminal, right? And the plate on the right will be negative terminal. Okay, so yes, you form a sine wave, same forces. So for this ball, what happened? All the negative charge on the ball will be assembled on the left. Okay, they are attracted to the positive terminal. Meanwhile, the positive charges all assemble on the right, okay, because they are attracted to the negative terminal. So now in this case, the forces acting to the left and to the right are equal. Okay, equal. So the forces acting to the left and to the right are equal. That's why it remains at the center. It doesn't attract to the left or it doesn't attract to the negative plates. Okay, are you clear now, Nicholas and
Yes,
others?
yes. Teacher, why the drawing?
Mana the drawing? Which one?
Just now you draw one.
Which one? Uh-huh.
The EHT power supply is positive, but to
Uh-huh.
the
Oh, sorry,
electric.
terbalik. Okay, the connection. Sorry, saya silap tengok the connection.
Oh,
Okay.
okay, okay.
Okay, thank you. Okay, so this one should be positive lah. Okay, and this one, okay, this on the left ini should be negative. So on the right ini should be positive. Okay, sorry for the wrong drawing. Okay, so we understand here the forces acting on both sides are equal. So that's why it remain at the center. Okay, so this is how you can explain this observation. Okay, so we can say when the EHT power supply is switched on, plate P is positively charged. Okay, and plate Q is negatively charged. So this is the positive terminal. So P is positive charge. Okay, so P ini positive, then Q is negative. Okay, Q negative. So you can see from the power supply here. Okay, so since the ping pong ball is neutral, so it remain at the center as the electric forces acting on it are equal, but in an opposite direction. Okay, so this is how we explain this observation why the ping pong ball remain at the center. Okay, so you can write this observation, but I think we go to the next slide. Okay, you don't have to worry because everything I have shared. Okay, I have shared the full PDF copy in your Telegram. So later you can write the full explanation for this question. Okay. So we move to the next slide. Okay, now this diagram. Okay, now we have the second situation. Okay, the ping pong ball, now we bring it to the metal plate P. Okay, we displace it to metal plate P. Okay, we pull it to metal plate P and then we released. Okay, so when you released, what happened to the ping pong ball? Okay, so this is the situation. Diagram show the ball is displaced so that it touch one of the metal plates. So we bring it to metal plate P. Remember just now P is positive plates. Okay, and Q is negative plates. So what happens, student? So this is how we can write the observation. So when the metal coated polystyrene ball is pulled and touched on the positive plate mean plate P. Okay, so the ball receive what charge? Positive or negative charge? The ball receive what charge from metal plate P? It receive positive charges. Okay, it receive positive charges, and what happened? It will pull towards the negative plate, which is plate Q. Okay, so what does it mean here? Okay, just now this ball, it has positive and negative charges, right? So when you bring it to metal plate P, which is positively charged, so what happened? The positive, remember, charge flow from where to where? From positive to negative, right? So the charge here will be flow to this ball and it will neutralize the negative charge on this ball. So which means now this ball is 100% positively charged. Okay, the positive charges from metal plate P jump into the ball and neutralize all the negative charges on the ball. So now it is become totally positively charged. So now positive, what happened? Repulsive force occur. Okay, remember repulsive force acting. So it will be pushed to the other plates or it will be pulled towards the opposite plates. Okay, so now it reached metal plate Q, which is the negative plate. So what happened when the ball is now at this position, students? Okay, it is explained by this blue wording. So when the ball is now touched the negative plate, which is plate Q, its charge is, so it has what charge? Its charge is neutralized. Okay, then the ball receive remaining negative charges and will be pulled towards the positive base. Sorry, my answer is quite shifted away. Jawapan cikgu sudah teralih di sini. It doesn't lies on the correct places. Okay, so now it reached the negative terminal. Okay, so this positive, now the ball ini from P, it is all positive, right? Okay, so it is all positive. So then what happened? Okay, at metal plate Q, if you read from here, its charge is neutralized. Okay, then the ball will receive negative charges and will be pulled towards this positive base. So same thing happened. Okay, now from here, what happened? So the charges positive and negative meet. So the ball will be neutralized, and then all the positive will be eliminate and remain all the negative charges on the ball. So here, after a while, the ball will become 100% with negative charges. So same thing happen, repulsive force occur, so it will be pushed back to metal plate Q. And this process will be continuously until when, student? It will happen continuously until?
The switch is off.
Yeah, until, very good, until you switch off the power supply. Okay, so this process repeated and causes the ball to oscillate between these two plates until we switch on the PHT or the power supply. Okay, so okay, this is the example. I think there's a video here, bukan? Okay, another one. Okay, so this is the factor effect. Okay, this is the factor effect, the oscillation of the ping pong ball in between the electric field. The first one, the speed of the ball increase when, number one, the distance between the two metal plates is closer or further. What do you think?
Closer.
Closer. Yeah, very good. Mean when the distance is closer or distance between the two metal plate is increase. Akan? Oh, sini increase. Speed of the ball increase when the distance between the two metal plates is increased. Betul ke jawapan dia? Mass of the ball is, later we check. Mass of the ball is smaller. Okay, voltage of the power supply is increased. Supposed to be this one is decrease. Okay. Okay, decrease. Okay, since earlier from this equation, kalau you tengok from this equation, remember this equation just now? For two metal plates, ini electric field strength. Okay, electric field strength directly proportional to V and inversely proportional to distance. So supposed to be the distance is decrease lah, not increase. So you please make a correction here on the first factor. So mass of the ball is smaller. Okay, mass of the ball is smaller, so the speed will be higher, increases, and the voltage of the power supply increases. Okay, as you can see here. Okay. Okay, are you clear with this? The factor effect, the speed of the ball which is placed in between of a electric field. Okay, this is another example, a candle flame. Okay, the second example. Okay, so we change the ping pong ball with a lighted candle. Now we place in between in these two terminal. Okay, so students, if you look at the question here, the ping pong ball is replaced with the candle flame. So stay to observation about the shape of the candle flame. So when I switch on the power supply, what will happen to this flame? So you will see that the flame will be spread out into two portions. It will move to the some portion will move to the positive terminal, some portion of the flame will move to the negative terminal. Will they move in the same portion? What do you think? 50-50 or how? In between the two plates, the candle flame. About 50% move to the left and 50% to the right. Is that so? Or another way round? What do you think?
Way round.
Okay, actually it's stated here in number 2. The spread of the flame towards the negative plate will be bigger. Okay, so let's say we mark this as positive. terminal, this is negative, okay, which means on the right is positive terminal, on the left is negative terminal. So you will see that, okay, the flame, the bigger portion will spread to the positive or to the negative terminal. Okay. The bigger portion goes to the left or goes to the right?
Negative terminal.
The bigger portion will goes to the negative terminal. Kalau you lukis lah macam ini, they say this is the flame. So bigger portion will goes to the left, while smaller portion will goes to the right. Ini bigger portion attracted to the left, small portion attracted to the right. I hope you can understand my drawing. Why? Okay, very good question, Nicholas. Why the portion are not 50-50? Okay, because students, I think you learn in chemistry also the size of a subatomic particle, positive and negative charges. Or namely in chemistry, you call it as ion. Okay, the mass are different. Okay, neutron is lighter compared to proton. Am I right? If you learn in chemistry, okay, electron and proton, the mass are different, and electron is much lighter compared to proton. Proton is a positively charged particle. So this is what makes, yeah, electron 1. Okay, how about proton? Proton is 1. Okay, so they are bigger in size. So this is what causes the portion are not equal. Okay, so macam mana nanti kita tengok dulu. Okay, first we mark. Okay, before we go to the explanation, we mark first X and Y. Okay, so plate X is positive plate. Why? Because on this one is positive, so connected to X, so X is positive. Meanwhile, Y is a negatively charged plate. Okay, so this one negative connected to plate Y, so Y is negatively charged. So draw the shape of the candle flame when it is displaced in the electric field. So this is the drawing. Okay. So this is negative plate, which is Y, and this is positive plate, which is X. So more portion will go to the right side, which is Y. Okay. Like leaf, yeah, it's like a leaf. Okay, but actually in reality, it is moving vigorously. Okay, this one. So when you are asked to draw the portion, you just draw to the left, bigger. Okay, the size is bigger, and to the positive, attracted to the positive, the size is smaller. So we can see an obvious difference. Okay, so this one negative charges, we have here positive charges. Okay, then what is the effect of the candle flame on the air around the candle? So first and foremost, when you place a lighted candle in between these two electric fields, so what happened? The flame ionized the air molecule around this field. Okay, it ionized. So sorry, wrong spelling there. It should be I-O-N-O-R. Okay, it will ionize the air molecule, okay, around this electric field. So we have free charge there, free positive and negative charge, okay, in between these two electric field, sorry. Okay, so by referring to the movement of the charges between the two metal plates, explain the shape of the candle flame observed. So why the portion is like that, bigger portion attracted to the left, smaller portion attracted to the positive, which is to the right. Okay, so how we can write here? Okay, I show you first the complete, okay, the complete screen. Okay, so this is how, okay, how the flame ionizes the air molecule. The heat from the flame produces positive and negative ion, mean it ionizes the air molecule around it. Okay, so then what happened? The positive ions are attracted to the negative plates. Okay, meanwhile, the negative ions are attracted to the positive plates. So the movement of ion are represented by the movement of the flame towards the positive and the negative terminal. Okay, so explain why candle flame is not symmetrical, because positive ions are heavier or bigger mass compared to the negative ions. Okay, so this is the reason. Why the portion are not equal? Because positive ion are heavier, or you can say positive ion has bigger mass compared to the negative ion. Okay? Okay, so that's all to do with the effect of charges on electric field. Okay, we have two examples. The ping pong ball coated with conducted material. Another one is a lighted candle flame which is placed in between two metal plates. So are you clear with the effect? Okay, you know why the ball remain at the center, why when it is placed from another plate, then it will continuously oscillate in between the two plates, and why when we place a burning candle flame in between magnetic field, in between electric field, you can see that the portion are spreading in, not in a symmetrical order. Okay, so now I think we can move to the fourth learning standard. What is meant by electric current? Okay, electric current. Okay, students, if you look at this diagram, this is also taken from your textbook. Conductor. What is conductor refers to, student? Conductor. Conductor. Electrical conductor. What does it mean, electrical conductor? It is a material which allow current to pass through it. Very simple. Okay. If you are talking about a heat conductor, so what is a heat conductor? A material which enable heat to flow through it. Okay, very simple. Insulator works the other way around. It doesn't allow current to flow through it. Okay, apa yang susah, Sinwei? Okay, class electric current. Okay, before we go to what is electric current, we look at the situation first. Okay, an electrical equipment can only function if current flows in a complete electric circuit. Okay, complete electric circuit mean you have the terminal, one connected to a positive, one connected to a negative of power supply, and the circuit is complete. Mean we switch on, then there is electric flow, then it will produce current in the circuit. Then only your rice cooker, your iron, okay, your heater will operate. Okay. Okay, so now let us take a look at the next part. Okay, current. Okay, this is what is meant by current. What is current, student? It is defined as the rate of flow of charge. Okay, rate of flow of charge. The keyword is rate of flow of charge. Okay, three keyword: rate, flow, charge. Okay, if they ask you what is meant by current, state the definition for current. So rate of flow of charge. Okay, ini addition lah in a conductor. You didn't write also no problem. Okay, again current, the symbol is capital I. It defined as the rate of flow of charge, and this is the equation. I is a current, Q ini is a charge. Capital Q is the symbol for charge, the total charge, and T itu is the time. So what is the unit for current? Q is in a coulomb charge. The full unit for charge is coulomb, and for time is second. So it is coulomb per second, or normally we are using ampere, as you learned before. Okay, ampere. The unit for current is coulomb per second or ampere, capital A. So 1 coulomb per second equal to 1 ampere. 100 coulomb per second equal to 1 ampere. If you arrange back, you can write Q equal IT. Charge equal to current multiply time. Okay. So this part involve calculation. The last two learning standard involve calculation. Before that, no calculation at all. Okay, what is electric current? So now you understand current. It is rate of flow of charge. So what is electric current? Current flows. Okay, how does current flows? Current flows because charge flows. So before current flows, charge will flow first. And charge here we specifically refers to electron. Okay, for example, you are having a battery, okay, a dry cell. Okay, battery. How does a battery function? If you connected this battery to a wire and connect it to a bulb, Okay, you can see that the bulb will be light up. Okay, the bulb light. Why the bulb light up? Because now the circuit is complete. Okay, the circuit is complete. So you connect a connecting wire here to the bulb, then the connecting wire here to the negative pin. We have positive terminal and negative terminal. So there is a potential difference occur in this battery. Okay, so when there is a potential difference, mean a charge can flow, electron can flow. And students, electron flow from where to where? Electron flow from negative to the positive terminal. And then later, current flows the opposite way. Okay, so when you connect this connecting wire, so electron flow from here, from the negative terminal of the battery, it flows throughout the wire and finally it reaches here. So the moment it reaches here, so the circuit is complete, so it will produce current. So current flow the other way around. So the blue arrow itu direction of electron flow and the red arrow show direction of current flow. Okay. So as you can read here, current flow because charge flow. Direction of current is opposite to the direction of flow of charges. Current flow from positive terminal to the negative terminal. Okay. This one is shown by this diagram down there. So any question on this? Are you clear? How does current produce? If the question asks you, can you explain how does current produce? Can you explain them now? Anyone? Chuan, can you follow me? Hui Xin, Yu Qian, So Yu Jie, Shamel, Xin Wei, Yufeng, and Zetian. Okay, we have 10 people with us now. Boleh. Movement of electron produce current. Yes, senang saja. The word movement itu normally we are using flow. Flow of electron produces current. Okay. Ataupun flow of charge produces current. Okay. Next. Okay, let us take a look at this example. Okay, what causes charge to flow? Okay, now we go back to the beginning. Okay, you know current flow because charge flow. Okay, then back to the basic. What causes charge to flow? Actually, I mentioned it just now. Okay, kalau you dengar tadi cikgu ada bagi tahu. What enable the electron or the charge to flow? Because there is a what? In between the positive and negative terminal of the battery, what exists between them?
Electron.
No. We call it as potential difference. Okay, potential difference. So when there is a potential difference between the positive and negatively charged, so electron will flow. Kalau dua-dua positive and negative, both battery has positive plate. On top is positive, below also positive. Do you think the charge can flow now, students? Or both part are negative on the battery. That's why if you connect the battery in the wrong way, you cannot see that the bulb cannot light up. Okay? Kalau you sambung negatif dengan negative, mean there is no potential difference exists. Mean there is no chances for the electron to flow. Okay, what is actually potential different? Potential different Sinway. As if in pressure. Okay. You remember the aerofoil shape. On top we have high pressure, below we have low pressure. Okay, below high pressure, above low pressure, right? So the pressure difference creates lifting forces. And for this one is positive terminal, another one is negative terminal. So it creates potential difference, electric potential difference. So that is the reason why charges or electron can flow. And finally, due to the flow of charges, it produces electric current. Okay, are you clear now, students? And okay. So what causes charge to flow? Okay, current can flow from one point to another due to a potential difference between the 2 points in the circuit. So where is our 2 points? A and B. Okay, A and B. Okay, as shown in this diagram. Okay, the potential difference V, what is meant by potential difference? It is work done. Okay, work done in moving 1 coulomb of charge from one point to another. Ini maksud potential difference. Okay, work done in moving 1 coulomb of charge from one point to another. Kalau you tengok ini, this is the formula for potential difference. Okay, so this is a positive terminal of this battery. Okay, the long line itu positive terminal and this is negative terminal. So this positive and negative terminal creates potential difference. Okay, so by definition, potential difference refers to work done, okay, or energy required in moving 1 coulomb of charge from one point to another in a circuit. Okay, so later we'll take a look at one example. Okay, what is the meaning of 15 ampere, student? Okay, let's say I give you 15 ampere. Okay, this thing has a 15 ampere, or this conductor able to flow 15 ampere of current. So what is 15 ampere refers to? It means 15 coulomb of charge flow in 1 second. Okay, before that, okay, are you clear with this potential difference? Work done in moving 1 coulomb of charge. And the unit for potential difference is volt. Okay, V-O-L-T, volt, or joule per coulomb. Joule ini for work or energy. And Q ini is a charge. Okay. Okay. Okay, so we go back to this exercise. Okay, so by this slide, so we are finished with the 5th learning standard. The 4th one is what is meant by current, and the 5th one is what is meant by potential difference. So what is meant by current? I repeat, rate of flow of charge, and the unit is ampere. And then what is meant by potential difference? Potential difference is work done in moving 1 coulomb of charge from one point to another. Mean the work done to move charges from point A and point B along this circuit. Point A and point B ini can be anywhere. Okay, one on the positive side, one on the negative side of the circuit. Okay. Why it is blinking? Something wrong with the connection. Okay, I make a check first. Okay, can we try this exercise one, students? Now it's 9:03. Before that, anything you would like to ask? So far, did you get the point? Students? Yes, okay. Okay, so now let us proceed with exercise one. Thank you, Nicholas, for your response. Okay, state the meaning of 15 amperes of 50. A minute, student. I share again the windows, the slide. Okay. Okay, now my slide is missing, right? Okay, can you see it again? How does it appear again? Boleh nampak slide cikgu?
Yes, yes.
Okay. Sorry, because I'm using my old computer since my one still in the shop, masih dalam kedai lagi, belum siap repair. And there is some glitch with this keyboard. Okay, it continue repeating the letter W. So that's why my slide is a glitch just now. Okay, kalau cikgu tunjuk masa ini okay ke? Not the slideshow. Is it too small or is it okay with you?
Okay, okay.
Yeah, okay. So we go back to this question. Okay, so for exercise one, the first question, they ask you to state what is the meaning of 15 ampere. So 15 ampere, just now current is rate of flow of charge. So it means that how much charge is flow in 1 second. Okay, that is meant by current. The rate of flow of charge, how much charge is flow in that circuit for every 1 second. So 15 ampere means we have 15 coulomb of charge flow in 1 second. Okay, that is the meaning. All right. They say state the meaning of 250 ampere. So it means 250 coulomb charge flow in 1 second. Okay, question number 2. Current flow in a bulb is 0.5 ampere. Okay, now it's the calculation part. Okay, which means this is I. You have to calculate the electric current flows through a light bulb in 2 hours. Okay, find electric current flows through the light bulb in 2 hours. Okay, so this is the formula Q equal IT. Okay, Q equal IT. So the question here, calculate the electric current flows, mean calculate the amount of charge flows. Okay, the amount of charge flow through a light bulb in 2 hours, mean we are looking for Q.
Teacher,
Yes.
the question 2 in our module is, in a metal wire, the charges are carried by electron. Each electron carries a charge of 1.6 times 10 power negative.
Soalan dia tak sama. Exercise 1.
Yes.
Not as seen here.
This is number 3. This is number 3.
This is number 3. Yours, this is number 2.
For our module, just now the question 2 in our module is number 3.
Then this one number 2, electric charges.
No, this is number 4.
Oh, mean I missed one question here.
Yes.
Okay, what is the question that missing here?
In
This
a
one.
metal wire.
In a metal wire. Can you read the question?
Okay. In a metal wire, the
Yeah.
charges are carried by electron.
Okay.
Each electron carries a charge of 1.6 times 10 power negative 19 coulomb.
Okay.
Calculate how many electrons in 1 coulomb of charge.
Okay. So that one, okay, for that one, calculate how many
In a coulomb.
electron in a coulomb. So for that question, okay, we use the equation for Q equal N E. Okay, Q itu is a charge, N itu number of electron, and E itu is the charge for 1 electron. Okay. Can you use that equation? Okay, I try to write the equation here. But if I switch on, it will be glitch. Okay, you wait for a while. Okay, sini ada pen ke? Sini tak ada pen. Okay, can you write the formula Q equal NE? Students, Q itu is a charge, N itu is a number of electron, and E itu is the charge for 1 electron. So charge for 1 electron is 1.6 times 10 negative 19 coulomb. Okay. So the question asks you to find
how many
current.
electrons in 1 coulomb of charge.
Or mean they ask you to find N.
Teacher, can you repeat just now what you say?
The question is Q equal NE. Q itu is a charge. Okay. N itu is a number. Like this, because I cannot see the question. Can we leave the question to be discussed in school later?
Boleh.
Okay. Sorry for that difficulties. Okay, we proceed first with my question here. For mine is number 2. So in your module it is number 3, right? Okay, we continue with this one first, can? Everyone can?
Okay.
Yeah? Okay. So we continue with this one first. We have a current flow in a bulb stated 0.5 ampere. So first you are asked to find the electric current flows through the light bulb in 2 hours. Calculate electric current flows mean calculate the amount of charge flow. So we are looking for Q, and this is the formula relate Q, I, and T. Okay, so the time here are given in hours, so you have to be very careful. You have to convert it into seconds. Okay, because here Q equal to IT, Q is in coulomb, I is A, and T is in seconds. So 0.5 is the current, this is I. So this is the time, 2 hours times 60 minutes times 60 seconds. So for this question, it will give you 3,600. What is the unit for Q just now, student? Betul tak unit yang dia beri di sini? I ini supposed to be A W, right? Okay, this one supposed to be I itu ampere, okay? And then E itu is second, right? Ampere per second. So now all the W is coming out. Okay, or you can. Cikgu punya tag ini sudah rosak. So what is the unit for Q here? You can write ampere per second or just simply write it as coulomb. Okay, 3,600 coulomb. Okay, so you clear with 2A?
Okay.
Okay, now B. Okay, we proceed with question B. Okay, if one electron carries 1.6 times 10 negative 19 charges. Okay, calculate the number of electrons which are transferred through the bulb for 2 hours. Okay, wrong spelling for hours there. Okay, so this is what I mentioned to you just now. The formula is Q equal NE. Okay, Q itu charges, N itu number of charges, and E itu charge for one electron. Okay, so we are looking for N. Since Q we have calculated earlier in the first part, so N ini equal to Q divide E. Okay, so Q 3,600 coulomb divided by the charge for 1.6 times 10 negative 19. Okay, so this is the answer. Okay, can you calculate, is this correct figure or not? The answer correct or not? 3,600 divide 1.6 times 10 negative 19. Is it 2.25 times 10 22? Correct or not?
Yeah.
Okay, so betul. So what is the unit for N? N ada unit tak?
No pa.
Tak ada unit, ni number sajalah. Mean we have 2.25 times 10 power of 22 electron, okay, are passing through the bulb for 2 hours. Okay. Okay, we get through the next question. This is question 3. In your module is question 4, right? Okay, so electric charge flow through a light bulb at the rate of 20 coulomb for every 50 seconds. Okay, this is the situation. Charge flow at the rate of 20 coulomb for every 50 seconds. So what is the electric current shown on the ammeter? So in this question, they ask you to find I. Okay, I. They give you Q. Q is what is the value for Q in this question? Charge, 20 coulomb. Okay, and the time is 50 seconds. So from the formula of I equal Q over T. Okay, so Q is 20, T is 50, mean the current flow is 0.4 ampere. Okay. So first you write the formula, you extract out the given information. Q is 20C, 20 coulomb, T is 50 seconds, so we are looking for I. So the equation is I equal Q over T, so 0.4 ampere. Okay, and for number 4, and lightning strikes, okay, strikes between two charged clouds. Okay, an electric current of 400 ampere flows for 0.05 seconds. So what is the quantity of charge transfer, student? What is the quantity of charge transfer here? So quantity of charge, so charge mean Q. And now they give you A, which is, they give you I, which is 400 ampere, and they give you T, 0.05, so we can find Q, the charge. Okay, so using Q equal IT, so we'll give you 20 coulomb. Okay, so this is a very basic question to understand electric current, charge, and potential difference for this question, number 5. Okay, so in your module, this one number 6, should be number 6, right? Betul?
Yes.
Is it? Okay. Okay, so we have done with current. We have two formula there. The first formula is Q equal IT. Okay, and second, Q equal NE. Okay, involving electric current. Okay, now potential difference. Okay, what is meant by 1 volt? Okay, what is meant by 1 volt? Okay, can you repeat or can you say again what is the meaning of potential difference, students? Anyone? Apa maksud potential difference? What potential difference refers to? This refers to the work done in moving 1 coulomb of charge from one point to another in an electrical circuit. Okay, can someone repeat what is meant by potential difference? The formula is Q equal W divide. Formula is V equal W divide Q. Work done in moving 1 coulomb of charge from one point to another in an electrical circuit or through a conductor. So 1 volt means 1 joule of energy required for 1 joule of work is done. Okay, 1 joule of work is done or 1 joule of energy is needed or required to move 1 coulomb of charge from one point to another in an electrical field. Senang saja. Kalau dia tanya what is meant by 100 volt, it means 100 joule of energy is required to move 1 coulomb of charge between 2 points in an electric field. 240 volt. Okay, that is the potential difference supply in every electrical appliances in Malaysia. So 240 volts mean what? Okay, 240 joule of energy is required to move 1 coulomb of charge between 2 points in an electric field. Okay, as shown in this example, we have 2 points, point A and point B. So 1 volt mean 1 joule of work done moving charge from A to B. Okay. So next question. Okay, students. Okay, number 7. Okay, now all these are refers to voltage. Okay, we have 3 questions before we end the session for tonight. Okay, question 6. If a charge of 5 coulomb flow through a wire and the amount of electrical energy converted to heat is 2.5 joules. So this is the information you are given. Find the potential difference across the end of the wire. So the first information you are given charge Q. Okay, remember charge is Q, 5 coulomb. Second, you are given the energy. So energy here, the symbol is W. Okay, 2.5 joule. So we are looking for V. So how to relate Q, W, and V? So from this equation tadi, okay, this one. So voltage is, sorry, I did it again. Oh, the W come out. Okay. My goodness. Okay. Punya keyboard ni suara rosak. Okay. So I'm not using this laptop anymore. Now it doesn't stop. Okay, sorry.
Teacher, so the coming soon exam until which part?
Sorry?
The coming soon exam
Until 3.1.
3.1.
So by this, by potential difference is the last part of 3.1. So these are all the exercises related to it lah. Okay, so so you can check from here. Sorry, cikgu punya mouse ini problem sikit. Okay, so this is how we find V. Okay, potential difference. So this is the energy or the work done. This is Q. So you just replace in this formula. So you will find the answer as 0.5 volt. Okay, I'm still typing down that. Am I answering your question, Nicholas? Okay.
Yeah.
Satu exam. Are you done with your revision? Are you started with your revision?
Sikit.
Mula. You better start with the Form 4 syllabus lah, especially. Okay, there are six.
Six
Yes,
of them,
six
which
of them.
is the major.
Honestly,
Cikgu, then you
soalan
send
cikgu
to
belum
us
hantar
lah,
lagi. Still finalizing. Cannot lah soalan kecil. I'm still finalizing sebab saya nak bagi dia
Okay,
susah
teacher,
sikit
but
daripada
which
from your
will
previous
be-
exam. Okay. Bukan susah lah, mean more challenging, not difficult but more challenging than the previous one. Because now your level of understanding is supposed to be higher up since we are getting closer to our trial exam. Okay, sepatutnya you sudah ready lah. Okay. But don't worry that much, you just prepare for your best lah. Okay. Tak adalah begitu susah until you cannot deal with them. Whatever we learn in the lesson, apa yang kita belajar itulah yang keluar. Mungkin ada a few application yang outside like the real SPM question. Sometimes the real application you never meet in any book. That one is kebat or hot kind of questions. Mungkin ada satu atau dua soalan. Okay. If I didn't put in the ujian pengesanan, so later on I will put them in the trial exam. Okay, boleh. Okay, can we continue with number 7 first? Boleh. We have another a few more minutes to end. Boleh. Okay. So are you okay with number 6, students? Boleh faham the working in all the W saya semua sudah kacau di sana. Sorry for that. Troublesome. Okay, for number 7, we have a light bulb switch on for a period of time. In that period, 5 coulomb of charges pass through and 25 joule of electrical energy is converted into light and heat energy. So the question is, what is the potential difference across the end of the wire? So again, they give you Q, which is 5 coulomb, and they give you the energy W, or sometimes written as E, 25 joule. So to find V, potential difference, so you just substitute into the equation. So we'll give you here 5 volt. Betul ke jawapan 5 volt? Did you get 5 volt? Okay, and the last one for number 8, when the potential difference across a bulb is 20 volt, the current flow is 3 ampere. How much work done? Okay, in this question that we are looking for W, okay, or E. So V is given 20 volt, I is given 3 ampere. So how to find? Okay, you can use this. Okay, so here we have a second substitution. Before that, we have E equal to QV, energy equal to charge multiply voltage. So this charge can be written in terms of IT. Q can be written in terms of IT. So it becomes E equal VIT, or W equal VIT. So you can find the work done now. Okay, since they give you V, they give you I, they give you T. Okay, so what will be the answer for this question number 8? Is it 3000 joule? Did you get 3000? Yes. Still doing? Calculating?
Yes.
Okay, senang saja kan. So, okay, this kind of question it will come out in paper 1. Selalunya soalan macam ini dia keluar dalam paper 1, a very straightforward one. Okay, but sometimes also can be come out in section A. Okay, section A, the first 3 question, question 1, question 2, or in question 3, the short structure question involving calculation. Okay, so I guess for tutorial 1, tutorial 3.1, you can give them a try for the objective question, especially on the structure question, because student, most of the structure and essay question here are taken from the SPM past year questions. Okay, kita ada masa 5 minit lagi. You nak bincang satu soalan essay tak? Atau one example of structure question. Can we try the last question?
Essay.
The last essay question. Okay, last essay question on this. Okay. Okay, this one. Okay, this is not essay. Ini for this one. Okay. Here. Okay. Section C, question 12. The last question in this module. Okay, you're given this diagram 2.1. It shows the candle flame placed in between two metal plates P and Q. Okay, and metal plates connected to extra high tension supply produces a strong electric field between P and Q when the switch is on. Okay, the first question, what is the meaning of electric field, student? Okay, again, electric field. So what is electric field? It is a region, area, okay, where a charge experience electric force. Okay, this one must be in your mind. Kena ingat lah. Okay, simple definition for electric field. The keyword is region, charges, experience, force. Okay. Okay, then the next question. Okay, this essay carry out 4 marks. 4 marks is explanation or working principle. Okay, they give you the situation, the candle. What happened to the candle flame when the switch is on? Okay, explain your answer. So how to get the 4 marks? Okay, so first, okay, what can you write for the first mark? Okay, the candle flame spread out into opposite direction. The spread towards the negative plate is wider. Okay, actually the first one, you can write this. Ini jawapan nombor 1. Heat ionize a molecule. Okay, this is the first mark. Okay, the first mark, heat ionize a molecule. Okay, you say the candle flame heat, okay, the airs around and ionize it into positive or negative ion. Boleh juga jawab macam itu. Or you can simply say heat ionize the air molecule. Okay, and then second, this one. So the positive and negative ion or the positive or negative charges attracted to the negative and positive plate. Okay, and vice versa. Positive charge attracted to negative plate, or you can say negative charge attracted to the positive plate. So that is the second mark. First, the flame or the heat ionize the air molecule into positive and negative charges. Second, the positive charges attracted to the negative plate. Or you can say the negative charges attracted to the positive plate. Okay, then this is the third point. Okay, the candle flame spread out into opposite direction. Okay, where the spread towards the negative plate is wider or bigger. Okay, then why? This is the reason, the fourth mark. Because positive ion is heavier compared to negative ion. Or you can say because positive ion has a greater mass compared to the negative ion. Okay, so this is the sequence, the correct sequence, susunan yang betul. First one, heat ionized air molecule. This is the second point, positive attracted to the negative plate. Third, candle flame spread out into opposite direction. More portion on the negative plate. Okay, smaller portion to the positive plate. And the last one, the reason, because positive ion is heavier or greater mass compared to the negative charge. Okay. So, kalau cikgu keluar soalan ini boleh jawab ke? What do you think? Can I come up with this question for the essay? 4 marks. Boleh saya keluar soalan ini tak? Can? Do you think you can get 4 marks if I come up with this question? Explain what happened to the candle flame placed in between an electric field. 4 marks. Boleh secure 4 markah from here?
Okay.
Confidence, kalau lah I say if come out. Kalau tak kuat sekarang, mungkin I come out of during the trial later on. Okay, but as I mentioned, this is SPM past year question, the actual SPM question. Macam inilah contoh soalan if come up from this subtopic. So the rest, I hope you spend your time and doing them. So any problem later we can discuss in the school. Okay, you are now, it's starting from tomorrow, you're going to have your ULBS, right?
Yes.
For Bahasa Cina.
Yes.
Is it for the whole day or what? Or your class on what day?
Whole day. Tomorrow.
Whole day tomorrow. Tomorrow only for 5
Yes.
update.
ABC.
ABC tomorrow, one day only.
If no mistake, yes.
Oh, mean only for, of each class only for one day lah. Oh, mean, okay, so the other question we can discuss on next Thursday lah for 2 period. Okay, so class, I think that's all for today. Okay, thank you very much for your effort and thank you very much for your time. So I hope you don't have problem with 3.1. What do you think? 3.1 easy?
So many formula.
Formulanya banyak, but the solution is just simple. One or two ways saja. Okay, can lah?
Yeah.
So you try to spend your time so familiar yourself with the formula so you can do more exercises on this. But actually for the real SPM, nothing really much to do with calculation. Okay, more on concept and application. So you don't have to worry much with the formula because most of the formula are given in the formula list. Only you have to understand where and when to use them. If you get the concept, I believe there will be no problem on applying the formula. Okay? So practice more on the concept and application. My advice lah, not only for this ujian pengesanan and also for your trial, but the most important for your actual SPM on coming February. Practice more on concept and application. Okay? So anything you can ask on the Telegram or you can ask later in the classroom on Thursday. Okay, student, anything else? Ada apa-apa lagi tak you nak tanya?
No.
I'm very sorry for the technical situation here because I am using my old computer. It is not working properly tonight. So very sorry for that. But again, thank you very much for your effort. Teacher really appreciate that. Okay. So good night, everyone. Have a sound sleep and see you again later in school. Okay, bye-bye for now.
Bye-bye.
Thank you semua. Terima kasih.
Teacher.
Yes, I'm still here. Sinwei.
The question that you say like 4-mark question also can keluar di ini punya ujian lah.
Yes, we will prepare. I will prepare a full format essay, mean 20 marks. Okay, for the essay, normally the portion for 20 marks, right? Okay, the first mark, normally for first question definition, 1 mark. Okay, what is meant by density? Contoh, atau if let's say if come up buoyancy, Archimedes principle. Okay, what is meant by weight? It can ask what is meant by buoyant force. Okay, itu mark number 1 normally on definition. Okay, so if in this case, maybe I can ask you, what is meant by electric field? The first mark. What is meant by electric current? Or what is meant by potential difference? Then the second mark will be, maka dia 1, 4, 5, 10 for essay. 1, 4, 5, 10. So if you total all, ada 20. Okay, 1, 4, 5, 10. 10 itu the long essay lah. 10 marks essay question. 1 mark for definition, 4 mark for explanation of working principle, and 5 marks for relationship in section B, calculation, 5 mark. Kalau in section C, 5 mark itu is on writing relationship. For example, okay, they give you 2 figure. Okay, compare the density. Okay, then compare the buoyancy. compare the buoyant force example. And then what is the relationship between density and buoyant force? Itu 5 mark for section C. 5 mark for section B is calculation. Okay. And for 10 marks, a long essay for both section B or section C. Okay, are you clear where you are going to get 20 marks from in the essay question?
Teacher.
Yeah, reform.
So,
Yes.
I have a question. So,
Yeah.
is it the candle is going to ionize the air molecule into negative charge or positive charge?
Yeah. Haha.
So, what's the effect after ionize the air molecule?
So actually, it is the ion that attracted, it is the air ion which is attracted to the positive and negative plates, and they pass through the flame. Okay, when the ion moving, they pass through the flame. So that's why the flame is also attracted to the positive and negative ion.
Also, that means that the air molecule brings the flame
Yes.
to the metal plate.
Yeah, correct. Okay. Because
Oh,
once they move through the flame. So they move through the flame. So that's why since positive ion, they are bigger. Okay, they are bigger in size. Mean lagi banyak yang langgar the flame. Okay, so more will pull the flame to the negative plate and less will pull the flame to the positive plate. So actually the movement of the flame itu represent the movement of the positive and negative charges of the ionized air in between that field. Okay?
okay, I understand.
Okay.
I want to go to eat already.
Okay, sorry to delay
Our
you.
group,
Okay,
our
enjoy your
group
meal.
haven't present yet.
Okay, so take your time. Nanti pilih satu masa. Just inform me whenever you are ready lah. Okay?
Okay, after percobaan bahasa Cina.
Okay. And all the best for your ULDS tomorrow.
Okay, thank you. Bye bye.
Okay. Okay.